This is Angular Motion Exam Sample Questions. An axle rotates at a velocity 15 revolutions per second, and accelerates uniformly to a velocity of 525 revolutions per second in 6 seconds. And we are to calculate the angular acceleration of the axle. And also to determine the angular displacement during this 6 seconds. Before any step, let us list all data given on the problem. We are given rotational speed n1, which is 15 revolutions per second, and n2 is 525 revolutions per second. The time given is 6 seconds. So let us quickly find angular velocity for each rotational speed. For n1, we say, angular velocity 1 equals 2 pi times n1, that will be 2 pi times 15, which gives an answer of 94.25 radians per second. So, and for angular velocity 2, we follow same procedure. That will be 2 pi times 525, which gives us answer of 3298.67 radians per second. Then, we apply these velocities on this angular acceleration formula. Angular acceleration equals 3298.67 minus 94.25, all divided by 6. This get us an angular acceleration to be 534.07 radians per second squared. Now, let us move to question number 2. We are requested to calculate displacement during this 6 seconds. This is an angular displacement formula, where we have this angular velocity, and this one, and also the time is given. Our duty, it is just to pick all data and pluck on this formula as such. After that, we get an angular displacement to be 10,178.76 radians. There is another way of calculating these, whereby, there will be no need to calculate the angular velocity aside. You just expand the angular acceleration formula as such. Then, on here you pluck on all suitable data. And also as for angular displacement formula, you just expand it as such. Then pluck on all suitable data. Now this following problem. An engine block weighs 775 kilograms. It is hoisted using a lifting device with a drum diameter of 325 millimeters. We are required to determine the torque exerted by the engine block on the drum. And we are to calculate the power if the drum rotates at 18 revolutions per second. So, listing the data given. It gonna be the weight force of engine, which will be force equals mass times gravity, that is 775 for mass times 9.81 for gravity. Then given diameter in millimeters, so we change it to 0.325 meters. And to make radius from that diameter, it is radius equals diameter divided by 2, that is 0.325 divided by 2. Now, the first question is about finding torque. The formula to calculate torque is, torque equals force times radius. So, we do have force, and we do have radius as well. Torque equals mass times gravity times diameter divided by 2. That will be 775 times 9.81 times 0.325 divided by 2. We get torque to be 1234.188 newtons meters. Now as for the power and given 18 revolutions per second. So, on this problem, power is given by power equals torque times angular velocity, which can be expanded to be power equals 2 pi times rotational speed times torque. So we say, power equals 2 pi times 18 times 1234.188. That get us a power to be 139.583 kilowatts.